OK, if there's one thing that you guys take away from today's session, it's on this slide, right? It's really that simple. What we're going to be talking about today is big data, quantifying big data, talking about some real-life use cases for big data, right? It's not very easy, right? In fact, it can be a pain, especially if your business is actually solving some other business problem, right? We want to suggest that there is a better way of doing big data than some of the methods that we've seen out there today, right? And what we want to show, with the help of some of our friends here, is how you can do that with Google Cloud Services and be very successful building applications on big data. All right? So we're going to be handing off a little bit. I'm going to kick us off by starting talking about what is big data. We're not going to spend a whole lot of time on this, but I thought it would be fun to go through a couple of quotes from a few of our customers and the businesses that we work with who have to deal with large amounts of data, right? So the first quote, and Richard here will be talking about them later on, is from Parcs. They're a hospitality company, a pretty large one in Europe, right? How are hotel reservations from Spain from New York compared with this time last year, right? That's a pretty precise slice of a lot of business data, right? Do we need to adjust our marketing campaign and where? That's a completely different set of data that may come from AdWords, DoubleClick, right? Campaign data, and then slicing that to a specific region. If you think about this, the nature of this question, it's a pretty precise one to ask of what we'll see later on as a lot of data, right? Which users who signed up last quarter also advanced at least 3 levels and purchased an item worth more than $5? Now, this is actually a real question, right? This comes from another of our early customers. They were actually in the sandbox yesterday. You might have seen them. Their name is Clarityx. They do user analytics for mobile and social applications. So they deal with tens of millions of users, hundreds of millions of events a day. And what they do using Google Cloud Services as a platform is they help their customers to understand their own user sets with very, very detailed questions like this, right, that help them find cohorts of users and target them for specific actions. One more. By the time we prepared the data, we'd forgotten what the question was. Anyone ever come up against this before when you're working with data? Right? This is a quote that literally comes from one of Google's largest AdWords customers. Right? These guys deal with hundreds of gigabytes of data a day from the logs that get served from the ads. And the reason this is really important to them, and they've invested a lot in infrastructure that helps them, right, in-house, but it takes a long time. The reason it's really important for them is they need to calculate things like ROI. How much are we spending in a given region, right? And do we need to change that to help the business increase? Right? So these are all really important business questions that are grounded on the basis of really understanding, right, getting insight from large amounts of data. I pulled these up just to give everyone here just a level set as what are we talking about. This isn't an academic talk. This is about solving real business problems by getting insights into data. Right? So I just want to go through this quickly, but again, in the spirit of getting some terms and quantifying things. What are some of these trends? As we step back from those questions, what's going on in business today? Right? As we've talked to a lot of these customers and worked with them, these are some of the things that are common themes that emerge. Right? They see opportunities. Right? Data is increasingly seen as a core business asset. It's not something that you just manage with IT. This is something that marketing, your data analytics team, your sales team need to do that job well. Right? Increasingly, a lot of critical business data is out in the cloud. Anybody use Salesforce here? Right? Lots of people, right? That just gets going. Think about social and so on, right? Google Analytics. New things are possible in the cloud because of infrastructure, algorithms. I don't have to go into this, right? But all of the things that you saw from the keynote, right? Many of these things are only available by using the cloud. Many businesses recognize that too. There are use cases in terms of sharing of data, controlling access to data, speed of decision making, right? As you saw with this laptop crash example, that's just a small one, but the speed with which you can move data around really affects how people can actually make use of data to make good business decisions. But there are a couple of challenges as well. right? Information, growing faster than the ability to leverage it, right? As you heard in Sundar's keynote this morning, and as you saw from that chart of Chrome adoption, right? Since 2004, if you see that spike, it's more users, more applications, on more devices, all generating data. Right? It's tough for enterprises to capture all that data. Even more challenging is, right, for the many businesses that do have BI and data warehousing infrastructure, the way of doing things before with star schemas, lots of indexing, proprietary hardware, what we'll see is that it's actually very hard for a lot of these installations to actually keep up with this torrent of data. So what do you do, right? And finally, skills, right? It's not just about money. It's not just about technology. It's about building the teams. It's about changing your organization, right, to adapt to these new tools and skills. As anyone here who's tried to hire for, say, Hadoop engineers, right, you'll know, skills are hard to come by. Right? So these are some of both the opportunities as well as the challenges, right, that as we've talked to many of these customers are recurring themes as we hear customers thinking about big data. Right? So let's get concrete about it. What does big data actually look like? Some of the common characteristics, right, comes in all different kinds: structured, semi-structured, unstructured data, right? Emails, tweets, so on. We're often talking about millions, if not billions of rows, right? And what kind of frequency, too? Right? Often it's too large to process on a single machine. Sometimes it's even too large to store on a single machine. What do you do then? Right? It's got a high rate of growth, and often it's growing every day. I won't read off the list of industries, but this is representative of sets of customers that we've talked to who experience a lot of these common challenges. So let's look at a real-life example of big data. Right? This is just a snapshot, just to give you an idea. But if anyone here has worked with DoubleClick, this is a snapshot of some of the ad-serving logs. Right? A couple of people do. Right? And as you can see, right, a single row, and I just took whatever fit on my screen for this, but you actually get a lot of data in DoubleClick, right? It's everything from advertiser campaign, timestamp, right? What was the impression, where it was. This is a snapshot from Google's own global marketing campaigns, right? We scrubbed it and anonymized it just to show you. But just to give you some of the numbers, right? Because Google is very representative of a large advertiser or an agency. Right? This is a very common problem. This is just from 1 week. Right? We have 300 gigabytes of data generated from these logs. The average about 6 billion rows, right? And almost 1 billion rows coming in every day. So that's a lot of data to deal with. And for the reasons that I mentioned before, right, the stakes are pretty high in terms of understanding what's going on in terms of all those ads and impressions served. Right? What if you had to query it? How would you do that? Fortunately, right, and we'll just do a fun little demo here. I'm going to show you how we can do this on BigQuery. So this is the BigQuery user interface. It's just a simple utilitarian interface meant for letting analysts and developers query against large data sets. Some of you might have played with this before. What we're looking at here, if you can see, is a daily snapshot of that data, right? And you can see the schema here. It's a pretty complex schema. If we look at the details, you can see, this is a single day's data is pretty large, right? So what I'm going to do is I'm just going to pull, and we're going to take that 1 day of data, and we're just going to do a simple count. How many rows is in this 30 gigabytes? It's a little hard to read, but that's just a little over 1 billion rows. Right? It's pretty nice, though, that we managed to count that in, less than 6 seconds. We'll do one more, and then we'll move on. What I'm doing here is I'm actually taking now that full week's worth of data that you saw from the snapshot. Right? And what this query is doing is basically it's saying, find all the countries, right? Count all of the impressions, and then here's the interesting one, right? Count distinct for user IDs, to find the unique impressions. So it's not just all of the impressions that were served, it's find all those impressions for the exact number of people that actually clicked on one of these impressions. And you can see there, we just processed about 177 gigabytes of data to find this question. Remember, 6 billion rows. We just went through this for a very arbitrary question with no indexes or caching, to find this answer. We got a nice list here, and we can see, for example, in the United States, that's what, 200-something million impressions, 2 billion impressions, actually, 150 million unique impressions. So that's just one example of how you can quickly get insights from a very large amount of data using cloud tools. But this kind of begs the question, if it's so easy, why aren't more people doing this? So let's take one more step back, and let's look at what's going on out there. This is just one quote from one analyst, but it sounds a little optimistic, I think. But 3 billion to 16 billion in 5 years is a little optimistic, but it just gives you a sense of how much investment and interest there is in big data solutions out there. And I just took a couple of the keywords that you typically read when you come across big data. So MapReduce, NoSQL, Hadoop. What do you do with all of this stuff? So what we see is there's a lot of questions being asked about how exactly do you go about from the problem of having a lot of data and knowing you need to get business insight to actually running that really quick query and interrogating the data, finding the valuable needle in the haystack. So what we see is there are some patterns starting to evolve. If you think about the tools that people are assembling to deal with big data, you can think of it as a kind of a software stack, an architectural stack. On the bottom, there's storage, the ability to store tremendous amounts of data. Once you have that data, you need to be able to transform it, do things like ETL, prepare it in the right format so that it's actually useful and can be loaded into tools. As we just saw with BigQuery, there's query and analysis. And then once you have those insights, what do you do with them? You have to serve them in the form of an application or a dashboard or a report, so serving the results. And if you see the two columns here, on the right, basically, if any of you have a couple $1 million in your budget to spare, you can go out and get a very fully featured, very capable on-premises proprietary data warehouse appliance, Lots of cores and everything to do this work for you. But if you have a couple million spare in your budget, there may be better things to do with it, On the other hand, we see a lot of work, really good work being done in the open source world. So many of these terms that you see here, NoSQL databases, HDFS, Hadoop, all the different modules, there's a lot of great work being done by the open source community to enable you to set up your own software stack. The challenge there is it's really, really complex. If you've ever tried to set up an HDFS cluster, run different Hadoop nodes and manage all of that, the task of actually managing all of that software stack greatly exceeds the amount of time you actually spend doing analysis. So to go back to that customer, by the time we actually got the data prepared, we'd forgotten what the question was. Directly applies to this. So what we want to suggest is maybe there's a better way of doing this, And to talk about that, I'm going to ask my colleague Navneet to come up. Navneet is the product manager for Google Cloud Storage, close associate of mine, and he's going to walk us through some of the tools that you can use. Navneet?
Thank you, GK. So we'd like to propose that a better way to do big data is really to leverage the cloud, and to use what we call composable cloud services, so cloud services with very specific functionality that you can put together to solve various problems, so you have a complete stack that solves your entire big data problem. Focus on the solution rather than the infrastructure, so you're not worried about deploying a new stack, learning new technology, learning, frankly, a whole new way of doing things, but instead you focused on the solution you're trying to build. And then to actually do things you couldn't do before because you have access to technology built by people who've been doing this for a while. And then finally, to make it cost effective, because you pay only for what you use. So rather than spending a few $1,000,000 on an appliance, you store as much data as you need. You process it when you need to. And when you think that answering a question is worth your time and money, you use the service. So I want to kind of call out what we internally often call the virtuous cycle of data. This is something which comes back very often from our customers in different forms when they talk about what they want to do with the data they have. So at a very fundamental level, they want to build great applications. They want to learn about how the application is serving their users, collect a bunch of data, process that data so they actually have access to it in a form where they can make sense of it, analyze the data, and then iterate, right? They want to improve the application, generate more data, improve the application, and so on and so forth. So we think that that's a really great way to think about applications. And so a lot of what we're going to talk about today in terms of the cloud solution is going to be focused on how you can make this happen for you. So let me take a step back and say, why is Google doing this? Well, so if you think about it, searching the web is at its heart a big data problem, right? Google had to learn very quickly how to store data very reliably, very effectively, and to go from that data to meaning. In other words, to understand the core insights hidden in that data, and to be able to share it with the world when we solve a search query, or to share it with our internal developers, engineers, operations folks, when we're trying to understand what's going on with the system and how we want to improve it. And we learned to do this at enormous scale and very quickly. And so, really over the years, we've been building out technology that it turns out is really big data technology. We released a number of white papers, MapReduce, the Google file system, Flume Java, Dremel, all talking about the infrastructure we were building. And it turns out that those same papers have turned around and become open source projects solving big data problems. Hadoop, for example, is based on our MapReduce technology. So we thought, well, what if we could actually give access to our expertise to the world? Could we make it easier for people to build great applications and do more with data? And so I want to propose that the combination of 4 services, 3 of which have been in the market for a little while, and one that we announced today, is actually a great way to solve this problem. You can store your data effectively, reliably, and with high performance using cloud storage. You can build applications and transform data using App Engine or Compute Engine, depending on what your needs are. And then you can analyze that data very quickly, as Juke showed you a little bit earlier, using BigQuery. And so to put that in the context of the virtuous cycle, the tools that you have are really App Engine and Compute Engine to build applications. You can collect data using a number of different mechanisms, from Google Cloud Storage to LogStore in App Engine. You can actually process data very quickly and effectively using App Engine or Google Compute Engine. Those of you who were in the Compute Engine session this morning saw a great demonstration of actually MapReduce running in the cloud and doing an amazingly fast sort, right? And then you can analyze the data very quickly and effectively using BigQuery. So I'd like to pause here and kind of give you an idea of what that looks like in production. And to do that, I'd like to introduce Richard Verhoff. Yes. From Crystalloids, a BI company, and he's going to show you a great application they built using the Google Stack.
Oh. Yeah, thank you, Navneet. So my name is Richard Verhoff. I'm from Crystalloids Innovations, and I'm the co-founder of Crystalloids Innovations. We develop an application called InsideOS, and we have built it on the stack you just have been shown. And the first customer we did this for was is an hospitality organization. It's called Parcs. I'm not sure if there are any Europeans in the audience. Some may know. And then for the American, you can compare it a little bit to a cruise liner. So it's a company, hence the picture of the children. It's real for fun. It's not a business-oriented business. It's a consumer-oriented business. And they manage around 10,000 beds. So every day they try to fill 10,000 beds. And they operate restaurants on their premises, hence it looks like a little bit like a cruise liner. So they have a great captive audience. And there's one thing, they're about 45 years in business now. They've created a huge European customer database. And from this, they accumulate a lot of knowledge about their customers. And they were doing a lot of data mining, a lot of forecasting on customers and who to address in certain mailings. So they were used to having a lot of databases. What happened with them? So at a certain point we were involved in this project, and they had a fairly good overview of what they tried to achieve. So they had a really done proper design of what kind of application would they try to achieve. They had a lot of internal tools. They had a proper data warehouse, they had proper staging areas, they even had business objects run properly, and the standard reports was very well, so that was not a problem. And then they started thinking about doing slightly different, combining a lot of the reports. They were scattered around across all kinds of departments. You know, sales is concerned about revenue, marketing about customers, the operators on the villages about clients. Others were concerned about the margins. And what you see in large companies that in this scattered world, they all have a slightly different view on reality and a lot of discussions and debates in the company. So commercial guy said, let's bring this all together. And by the way, if we got so much data and we determine and predict on customers, why don't we do this on revenue? So that we can, so you see here in the first designs, I think this is 5-6 years ago, you saw a first design. So what happened? What you see in these large companies, they start having an architectural picture, and of course they want to use proven technology. So Netezza data warehouse, business objects, and let all the data flow. Well, I was there at that time, and I think tried 5 or 6 different solutions, from Microsoft Analytics Server to Business Object itself. Well, it's too much to name. And they had all one thing in common. They all failed. So everything failed. Everything they tried and we tried, everything failed. And why did it fail? Sometimes it was too expensive. This was a new insight, not something which you could put there and it would earn money. It was just insight. And I like the phrase, the benefit of insight is insight. You still need to do something with the insight, and if you don't do anything with the insight, it's just insight. So some of the vendors came, yeah, we can solve this problem with your forecasting. It will cost you €1 million to just buy the software. So that failed on the expense. Another one was like, the machine just stopped because it didn't work. And the other one, you increased so much systems, that you increased system management so much, that the IT guys were like, okay, sorry, but that's not acceptable. So that all failed. So we thought, let's try another approach. Completely different approach. We almost abandoned the project with them, just stopped and said, well, okay, let's do it differently. So what did we do? First, we thought, let's do it differently. So instead of having analysts looking at the problem, we took a developer to look at the problem. And we gave him one rule. You're only allowed to use Google technology. And why did we do that? In that company, they already had some experience with a transaction application on Google, and what was liked about it, it was in the cloud, of course, on the first machines. And we learned about big table. And we thought, well, if Google can make such quick applications, why not we? Because they apparently seem to solve the solution. So we started learning about column-based databases. And we thought, well, we put all data in big table. That didn't work either. And then we were lucky. Sometimes you have a break. We learned about BigQuery. And it looks like that BigQuery would do. But then there is always an issue when you're a European company. Google didn't allow us to use BigQuery because we were overseas. So we had to persuade a little bit more, get some more phone calls, get the Google in Europe working for us. And finally, we were made trusted tester. So we were, 2 years ago, trusted tester on BigQuery. And we set ourselves the rule, only use Google tools. So App Engine, Google Web Toolkit. We found out that there is a great chart APIs there. And I still remember the presentation of one of the Google I/Os a few years ago. There is an API for it. So we thought, if we can't fix it, let's limit ourselves to Google. So we did. Oh. And we succeed. And I will show you in a minute the demo of the application. The application is there, so it's an application which is now also in other hospitality services. It's an application which is being used by the real end user, so it's not a tool which we implemented for a business user. And I think what happened is that the flow of all the data from all the back offices is now into cloud storages. Some is being uploaded into BigQueries, others stays in Bigtable. And suddenly you get the feeling like Google does with customization or consumerization. And suddenly BI becomes really in the hand of the, let's say, the internal end user, so not the consumer. But you suddenly see how this works for real people who have not a technical background, not even in computer science or in more technical marketing departments. And they suddenly can go through all the data. So let me show you now the demo. You have to switch, I think. So, so bear 1 second with me. So I take now one viewer. And what is this viewer? If you're in travel, people book today for a holiday in 6 months, of course. So what you see on the screen is how, and this is on demo data, how the bookings of last week are for the future. So we had this idea, so we would like to look for backwards, of course. So what did happen? What did we brought in sales? And where will it land? So what you instantly see here is that on this, we took together a few years of data and we compared July last year with July the year before, and it instantly showed up the graphs. So and I don't have that much time, so what I will do, you saw that July was behind, or I will tell you that July was behind, and I will move to a different view. And this is, I'm gonna select now the month of July and apply this. And what UK just did with the BigQuery, this is BigQuery work. So picking July in the background, it generates, of course, a BigQuery query. And it just picked on the month of July of the last 3 years. This is for normal business users who use Excel very difficult to do. And especially when you see, well, I thought July was behind, but apparently it's not behind. So how come? Well, maybe there is a difference in weeks. So here I apply the last week of July, and it compares to the same week of July last year. And these are actually, every time I hit apply, it goes back to the back end, and it comes up with the data. And, oh, there is no data here, which I don't understand. So let's do it again. Yeah. So it's not the second week, so maybe it's the first week. And this is the way end users want to understand their data. So I've just done a lot of data queries, and then you see July is behind in the first week, but I saw a bigger difference. Well, where's the difference coming from? If you operate in Europe, and it must be the same in the United States, you got states, and Europe you got countries. So let's interrogate some countries. Well, there are a lot of countries. This company have from these countries, and here is some next, so I will drill it down. And what you saw in UK's demonstration is now here fetch from the backend. So this is real fetching it. So, well, there's a lot of countries here. Can I make it slightly easier? Because I want to zoom in. I already want to zoom in on a certain region. And I thought, well, maybe it's Germany who's causing the problem. So, yeah, Germany was causing the problem. So here suddenly the end users making now queries to the backend and have an overview in a very simple view. Then you wonder, well, what's caused this? Let me see, is there a certain region which causes this problem? And I know, because I prepared this, of course, that there is a certain region which is causing this problem. And now in the hand of the end users, they are using BigQuery without having any knowledge about SQL knowledge, tooling, cross tabulations, And it's so quick for them that sometimes when we first had this application running, I still remember that one of the Germans said to me when it was with this custom implemented, wo schaust du denn hin? Ich hab doch gar nicht die Daten. Which means in good English, what system do you look in? Because I don't know where you get the data from, because they were looking at the old reports, the green, red reports from business objects, and they couldn't figure out where I got the data from. Because during the meeting, we had this conference call, during the meetings, I could look through their data and tell them from what agents, for instance, in the countries, or what actions, like was the booking made on the internet, was the booking made in a call center, was the booking made via the travel agents, what kind of actions were revolved around making this graph. And if I then was thinking, okay, this is about Germany, but what about Belgium? Well, in the old days, we would have go to the business analyst guy, had to ask him, can you do this again for Belgium? And then he would look at me like, okay, so you just asked me to do everything on this, on Germany, and now you want me, yeah, and can you have it today? Well, what's here now is really, you do it, is it okay? Okay, you just push this one, and you got Belgium and Germany together. So, yes, okay. So, instead of doing minutes or hours or no answer on traditional data warehousing tooling, instead of wait days on certain reports, you can interrogate, and I have to say there is about 40 million rows underneath this demo in BigQuery. So it's not a Google set, but it's still for a company a large set. And it is really the real end user who's using the tool and not the business analyst. And I made some calculations. Not buying all the new software and not buying all the hardware saved about 800,000 in the project. So they're very pleased with the tool. Thank you.
Thank you, Richard. So, I mean, you can imagine that taking data and turning it from a turnaround time of hours to a turnaround time of seconds fundamentally changes what you think you can do with your business, because you can react to end users almost in real time. You can adjust your business to deal with what you're hearing and seeing from the market now. So let me very quickly, give you an overview of the services we talked about. The data was stored in Google Cloud Storage, multiple layers redundancy, like all the services powered by the Google network, which is extremely reliable and high performance, built to serve our own sites over several years, and we think it really shows. You can store as much data as you need, so as your data needs grow, and as you decide you want to bring more data to bear, you can do that without worrying about capacity and provisioning and overcapacity and overspend and underspend. And you can share your data quickly and effectively. You can use App Engine's various tools to both build applications as well as transform your data. You can actually even make use of what's by far the world's largest hosted NoSQL database, the App Engine Data Store, which effectively gives you the ability to store structured data and query it effectively and quickly without having to worry about schemas. You can have atomic transactions, but you can get that at the expense of giving up the ability to join across tables. But the good news is you can actually do joins in the cloud, especially with large data, right? Using either App Engine or using Google Compute Engine. You can actually, if you already have invested time, money, technology in the Hadoop ecosystem, you can bring that to the cloud now and run it in the Google Cloud close to your data and go from, again, your raw data to your processed data, so you can now actually make sense of your data very quickly. And then finally, we talked a lot about BigQuery, but the bottom line is that's where you actually get the insight from. So putting that all into the form of an analytics pipeline, you store your data in any number of places, depending on the kind of data you have. If it's structured, it ends up in data store. If you're trying to gather application logs from App Engine, you can store it in log store. Or you can use Google Cloud Storage for storing any generic data you have. You can then transform and process it using either App Engine or Google Compute Engine. And then you can query it using BigQuery so that you can build your applications. So as Juke spoke a few minutes ago, there are multiple ways to do this. There's open source, there's proprietary technology. We feel that both of them have their drawbacks. or you can just use the Google stack. So all the technology you saw today looked like a very well-integrated suite of products, because it is. But it turns out you don't have to use all these products together. You can use them individually. Each of them has their own API. And to talk more about how you can actually use an API to build a great application, I'd like to invite one of our partners, Nicolas Respal, to talk more.
Yeah, thank you. So my name is Nicolas. I'm the CTO of a company called Beam. And our mission is to deliver business intelligence via the cloud. So really our goal is to empower business users to analyze the data at any scale without having to think about technology. So we do that through very intuitive and powerful user interface, and I will show you that in a couple of minutes. So we connect to a lot of data sources. We connect to relational databases, we connect to App Engine, Google Spreadsheet, Google Analytics. So we try to really embrace where IT is today. And when we were in a quest. We were in a quest to find something like BigQuery. So it's a kind of bold statement. We really think that BigQuery is a revolution. Why? Because, as I said, we were in a quest. We tried a lot of different technologies to be able to do BI queries. So BI queries, if you think about it, it's, well, large range query that aggregates a lot of data. So typical queries, give me the sum of profit over time, for example. And the second characteristic is it has to be really, really fast. The problem is most of the technology that was available, it's, well, either kind of expensive. As Juke mentioned it can be expensive or complex if it's open source. And with BigQuery, well, basically it removes all those obstacles. You get very scalable backend to do all your kind of queries. So seeing is believing, so we'll try to show you a really quick, very quick, demo of what we can do on top of BigQuery. Yeah, if you can help me, Juke. Okay, wonderful. So we are in a web browser here, and I will just pick up one connection available in this account. And what you get on the left here is all the columns available in the BigQuery database. And the way you do query, it's really simple. You can just grab a column and you drop it to the layout. And by doing that, you do your first query. So here, I'm just summed all the order quantity available. So we are on a retail data set. And if I switch the aggregator, so here we use sum, but if I switch to count, we will count the number of rows available in this data set. So we are sitting on top of 500 million rows here. So as you can see, it's really fast. It's live, no trick, no pre-aggregation. Everything is done on the fly. So as I said at the beginning, we really try to empower business users. So for one time, we will forget that we are sitting on a really large data set. Well, it's not gigantic, but for live demo, it's kind of, well, that's the first thing that BigQuery can give you. You can do demo on very large data sets. And the first thing you want to do when you think about a data set like this is, well, what is the time frame we are on? So by just dragging another column to the mix, I will explode through the order quantity by year. So this is it. And I will switch to a different visualization. We are already focused on data visualization. We have 16 type of visualization with hundreds of customization points. So you can do, map, you can do relationship analysis, you can do tree map. But well, for the sake of simplicity, I will stick with a simple column chart. So this is the exact same result, but now through a column chart. We see that in 2012, we don't have a lot of data because it's not done. So let's drill down into months to try to picture the trend of the data. Here we are working on sales data set, but well, it can work with pretty much anything. It can be telco data, it can be AdWords data, it can be really anything, and you will get, well, the same kind of flexibility. But let's go back to this example. We see that, well, the order quantity are well, pretty steady, except that in April 2012 here, we have an increase. So the goal of the demo is to try to understand why we have this peak. So I can interact with the chart. I can really use the visualization to interact with the data that is stored in BigQuery. And each time I do something like, well, I will decompose this point. I will go behind, literally behind this point, and decompose that by, let's say, sales channel. Each time I do something like that, I'm eating BigQuery, and I'm processing something like 8 gigabytes, 9 gigabytes of data on the fly. And, well, it's amazingly fast. If you try to have this kind of capability in-house, and if you try to do that for several customers on the same infrastructure, well, you have a lot of pain to do that. And this is what you get out of the box. And, well, if you look at this chart, we have a beginning of an answer. We see that one of our sales channel is holding most of the data. So if I just switch to another visualization, well, yeah, it's 90% for one of the sales channel. But, well, still, we don't have the complete answer. We know that we have one sales channel that is holding a lot of data, but maybe we can have a look at how it compares with previous months. So to do that, I can just grab months here, move that to another place in the user interface, and I'm going to use a feature that we have that is called explosion, and basically it will generate one chart for each element in the explosion. So here I'm going to select several months, and this will generate one chart per month. Here we go. So I will just select 4 months here. And why am I doing that? It's because you will see that we will be able to compare each month with each other very easily through different charts. So again, step back. We are eating 500 million rows on the fly, and we don't have even, well, we don't have to care about the infrastructure. We used this data set a couple of days ago to do a blog post. I will show you that at the end. And we were publishing a dashboard on the Google blog post to, I mean, potentially millions and millions of users. And, well, you can't do that in-house. You have to rely on someone like Google to do this kind of thing for you. So here we go. We have our 4 charts. So let's space that a bit. And we have the answer on this chart. So I'm just, the resolution is low. I'm just switching to another view. So this is January. If you have a look at that, the private only shop sales channel doesn't exist in January. So I will move to another month. February still doesn't exist. March still doesn't exist. And, well, in April, well, when we have our peak in terms of sales, we have a new sales channel. So that's kind of the explanation. Maybe our company have introduced a new sales channel that is working very well, and that's the explanation. And, well, that we have a beginning of an explanation. And my goal was just to show you that you can really interact with massive amount of data, no pre-aggregation, no cache, and you, well, all the time we think about it in terms of business, not in terms of technology. And, well, a couple of months ago, it was not doable to do this kind of thing in the cloud. And now I believe it's kind of the tipping point where business intelligence is not only doable in the cloud, but it's often better, faster, and cheaper than on-premise option.
Great. Thank you, Nicolas. So I'm just going to summarize very quickly. But what Nicolas was showing, he actually made it look easy, right? I'm glad he pointed it out, but that was a very large set of data. And using the set of tools from Beam, or what Richard showed before, was a custom application with this very specific company and domain focus. It becomes actually quite easy to actually transform and shift our thinking from, it's no longer a technology problem dealing with data. We can really shift our focus to where it ought to be, which is solving a business problem, right? We talked about the technologies that Navneet brought us through. Nicola demonstrated how to build on top of APIs. And what we also realize is it's very important for businesses that there's a strong ecosystem to support them as well with other kinds of tools. So I just wanted to highlight this, that we're also working with a fairly broad array of partners in the data storage space for things like NAS replacement or online backup, right? In the ETL, so extract, transform, load, some of the leading vendors in that space who are ready to announce connectors into systems like cloud storage or BigQuery. So take your data from on-premises or in other parts of the cloud into our systems, make that really easy and automatable. And then as you just saw with Nicola, we have partners in the visualization space as well to make it really easy with out-of-the-box tools to slice and dice really, really big sets of data, quickly get to those insights. So just quick summary. What we went through was we talked about some really big data problems. Hopefully one of the takeaways that you have is that it's really about focusing on solving business problems rather than building technology to just analyze data. Right? For the line of business, right, it's important to remember that using Google Cloud Services, you can actually start relatively small. You don't have to build out a big data infrastructure from day one. Google Cloud Services lets you take an incremental approach, and we'll scale with you. Right? And that's true from everything from cloud storage, BigQuery, App Engine, Compute Engine. Right? And they get really, really big applications as well. Really important, the more questions that you can ask, the smarter those questions become. This is kind of turning BI on its head. Right? It used to be that you had to kind of know the questions ahead of hand before you could create the indexes and the cubes and then serve that up to the business users. By putting data in the cloud, that actually turns it on its head. Right? This is something that we do at Google all the time. We start out not really knowing sometimes what is interesting in the data, and it's only by asking lots of small questions on really big sets of data that we can understand what's important. Right? And through these tools, we're allowing you to do the same thing with your data as well. Right? If you're in the technology side, IT and development, hey, this is New School BI, right? Store all the data, right? Worry about joining it, processing it, analyzing it later on. That's really the name of the game now, especially when you have more things like social media, Firehose, right? You've got mobile devices. The name of the game now is just finding a place to store it all, and we provide you very scalable systems to do that with things like the data store, cloud storage, right? The cloud enables you to set up pipelines to then process that on an automated basis and to do it very rapidly, build these things very rapidly. Finally, you can actually build apps on your data to set the data free. Again, this is something that's quite new. Right? It used to be that data was trapped in traditional data warehouse systems with a team of analysts or IT people who were kind of the gatekeepers to it. What these tools allow you to do is actually open up access in a secure way and a scalable way to the rest of your organization, right? And actually develop the specific applications needed to solve those business problems. So hopefully this session was useful today. I'd just like to thank again Beam and Crystalloids for joining us today. And thank you for your time, and we're happy to take any questions. I did forget to make a plug. We have some other great sessions about big data. We did yesterday have a session on doing MapReduce pipelines in App Engine. That should already be, the video should be encoded and posted onto YouTube. Tomorrow, we have a deep dive into the BigQuery internals. We have some of our engineering team here to talk you through some best practices for doing really, really big, interesting queries. We've got a session on cloud storage as well. And we've also announced today some really interesting sessions on Google Compute Engine, which is the new VMs. If there are any questions, please come up to the mics. Thanks.
I think the question is related to the querying of App Engine logs, which was announced yesterday in the App Engine overview session. Logs are very generic in nature, but if you want to analyze more specifically based on the domain data that you might have, based on some business data, right? Would you have to write a specific set of API to big data to have your own data structure? And if so, what are the patterns possible? Because BigQuery doesn't allow throughput beyond 3 or 4 requests per minute. So do you have any patterns that you would want to suggest by writing to something like Memcache and writing it asynchronously or something? something
Yeah,
of that
so,
sort.
so the question is about, I think, what are some of the patterns for getting logs data, which might be in a domain-specific format into BigQuery
Yeah,
effectively?
that's the first part, and the second part being the technical know-how of writing to the BigQuery, because the throughput to write is lesser in the case of BigQuery per minute.
So maybe the part of the second question is that there was a significant ingestion throughput, which basically the way it works is you send us an ingestion job, and we'll put that on a queue, and we'll process that when free cycles come by. It is subject to certain rate limits, but you can actually, through a combination of compression and parallel import jobs, you can actually be importing significant amounts of data, hundreds of gigabytes of data at a time. So give that a try and see.
Okay.
To your question about preparing data, actually highly encourage you, if you didn't, to look at the MapReduce pipelines session.
Okay.
One of our developer programs engineers actually walks through how you do some basic preparation of data from the log store and do some massaging. And I think one of the example is just massaging some of the date times, but it's representative of reformatting the data, right? Putting that into a MapReduce pipeline and ingesting it into BigQuery.
That's the 27th?
Building data pipelines at Google scale.
Okay.
Yeah, so check that one out on YouTube.
Hi. Can you reveal more detail about the compute engine and this BigQuery, how they work together? Yeah.
So we actually, if you look on the updated sessions that were posted today, there are a significant number of sessions on compute engine itself. I forget which one, but it's later today. There's actually one where we actually have a demonstration of running a Hadoop job within compute engine to extract a bunch of, I think it's Wikipedia revision data, which is a pretty large data set, and then ingest that into BigQuery as a practical use case. So if you're interested in the compute engine for doing data processing jobs like that, I recommend that you go for that session.
I just put up the session names on the screen. If you see the bottom right corner, those would be interesting sessions for you.
All right. If no other questions, thanks for your attention today.
And thank you.